Good evening, and welcome to another edition of Matt's Old Projects. So this is a piezo thing that I did. You have these piezo discs that they normally use. Piezo, some people pronounce it that way. Piezo discs, I say piezo, whatever. These are discs that are made out of crystalline substance. So this white center piece here is a type of crystal. I don't remember what they use on these ones, but you can make a. Actually, let me start from the beginning. I always suck at explaining stuff. Piezoelectricity is to convert the vibration or any kind of movement of a crystal into electricity. That's what piezo or piezo means. Okay, so at home you can make a crystal that has these properties. I think pretty much all crystals have these properties because as you squish the crystal, it does something to align so that the electrons can move to one side or the other based on the crystal structure deforming. Okay, so at home you can make piezo crystals yourself called Rochelle salt, and that is basically you cook stuff in an oven. You cook baking soda in an oven for like 3 hours, and that makes what's it called? Soda ash. And then you can put like 3 teaspoons of cream of tartar in it, and then wait and keep adding cream of tartar until there's no more reaction. But you want to slowly add it, and then until there's no reaction, and then you have a super saturated solution of cream of tartar and soda ash, and then you let that dry off all of the liquid. You normally have to seed the crystals with another salt, or like a piece of uh, um, baking soda, a pre-existing crystal will seed it so that it starts forming better. Or you could just wait and it'll randomly form at one, a couple of little crystals. Anyway, the point is you end up with these crystal things that when they are squeezed, they generate an electrical voltage potential across the crystal. Now, it's not in a particular direction. It might be random. Okay, so, but as a result, you make these things called piezo discs. I actually have one over here on this cluster of junk. Here's one. Here's one by itself. Okay, so this thing right here. And the white stuff on the top is the piezoelectric crystals. And then it's basically like a metal plate, and that's it. And then you got a ground lead on the metal plate, and you got a red lead on the side with the crystals. So as you squeeze this, as you deform it or put pressure on it or vibrate it, it's going to generate a voltage. But the voltage might be AC. It might go up and then negative. So depending on it's not just a DC signal. So you'll have to rectify that. They normally use these devices on things like guitars. And what you'll do is you put this on like a cigar box guitar, and it will vibrate with the frequency of the sound that you're playing, and that will generate a electrical signal that is then rectified and then amplified to create like an electric guitar, right? But you can go the other way. You can go from I am powering up this thing with a battery, and it will vibrate. And they use those in let's see, what do they use them in? The humidifier things. So if you put a 9-volt battery across this thing will vibrate really quickly. It can actually like cause water to boil at a lower temperature or something like that, and let off steam, and that's what's in those humidifier things. I don't know if I have the process there correct for how it does that, but anyway. But you can also use it to generate electricity. It's not a lot of power. So you'll see right here I have maybe 1, 2, 3, 4, 5, 6. I think probably 8 of these piezos together, so that I can like squish them all together. And then each one of those I had, I think, paralleled out to these little creature-looking things, which are actually rectifiers. So each one of those has 4 diodes in it that forces the possibly AC signal to always just pull the positive off. Okay, and then you get a positive no matter if this is going, if it's squeezed the right direction, whatever. So it combines all these together to always be a positive signal. Then those are parallel together, and then you shove an LED on the end. Doesn't look like I have any resistors here. And then when you squeeze it, if I can do this, I'll put it more in the dark because this doesn't work that well. There we go. Squeeze it, it lights up, yay. Now it'll do that pretty much forever, unless you squeeze the crystals too hard and you crack them, and then they don't work anymore. Alright, so after a period of time, these things kind of stop working. But, I mean, they'll work. I mean, if you don't put excessive pressure that actually destroys the crystals, then you're fine. Here's another one that I made. This is some other attempt, probably like 5 years ago. And this one I have 1, 2, 3, 4, 5, 6, 7, 8 on one side, another 8 on the other side. Assuming that I went out of these and recombined them in parallel like I did with the other one. But the whole point of this, I guess, was I could squeeze on both sides. And then, did I do anything else? Did I put a resistor in or anything like that? I don't know. So let's see if I can get this LED to light up here. This is a white LED. Squeeze, 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 squeeze. Yeah, so that works okay. I don't have to squeeze that hard. But it is kind of hard to do it. It's, I gotta squeeze a little hard to get it going. Now you'll notice also it lights up when I squeeze and also when I let go, because those crystals they deform in the other direction, which might end up being negative voltage. For one of them, but then that is still rectified into a positive signal based on the diodes. So it'll light up both when I put pressure and then release. Okay, now the amount of power in these things, so one of these will go anywhere from like 2 volts to 10 volts, I think. Me playing with these things, 2 volts to 10 volts. And amount of current, like nothing. I think it was like, well, I guess this is lighting up an LED. I think that's a minimum of 20 milliamps to light, or something like that, maybe 30 milliamps for a white LED. So this is, let's see, divided by 16. So at least 2 milliamps for one of these. Something like that. But it's not a lot. It's not a lot of power. Okay, so you're not going to charge your phone with this. You will get a high voltage that can light up something, but that light is not actually a lot of power. LEDs do not take a lot of total power. They just need high enough voltage. So like white LEDs are 3 volts. So as long as I get over 3 volts, this will light up. But yeah, it's not a lot of power. You're not going to be able to charge up even like a 100 microfarad capacitor would probably take you 30 minutes of squeezing to charge that up to 10 volts. I think from what I remember. Anyway, so this is piezoelectric energy harvesting concept. All right, and I'm done.